Sorry, Quinn, I forgot to show you where this formula comes from. My bad, but I don't think the students want to go through it again. So come by my office, okay? And we can talk about it. All right, so here we go. Last thing we're going to do, very last thing. Since we already have talked a lot about the rose curve, 2 cosine 3 theta, we found the equation of tangent lines to that curve, okay? By the way, can you just take and just give me, like, imagination? Where might you see something like this in real life? I mean, just stretch our imagination a little bit. Where might you see something like this? Yeah, Chris. Like a windmill. Like a fan. Do you guys ever see those water bottles that have a spritzer on it, and then they've got this little windmill at the thing, and you press it, and it goes zzz, like in Disneyland, and it squirts all the water out in your face? You know what I mean? Like the water bottles with the thing. Or maybe it's just a fan, right? I mean, can you picture it in a box, and it's a fan sending us water? Maybe it's sending water, not just water, but air through something. Are you with me, my engineers, right? So we've got some shapes going on here. Okay, so what if we want to know what the surface area is? How much water is going through, flowing through something, or air flowing through something? All right, so we need the area for this shape. But if we can find the area for one petal, then we can find the area for the whole thing. So let's just focus on one petal right now, okay? So right now, I want to set up an integral that can be used to find the area inside one petal of the rose curve, r equals 2 cosine 3 theta. And let me again pull up my things so that this is over here, and we've got Desmos over here, so we're looking at it. So first thing we have to do is we have to write down our limits of integration. So the area is, according to our formula that I very quickly went through, but you also have down the bottom of your formula sheet, the area of a fan-shaped region between the origin and the curve is given by as follows. Area is 1/2 r squared d theta from alpha to beta. So I'm going to copy that formula down. Area is the integral from alpha to beta of 1/2 r squared. I'm going to emphasize that r is in fact my function of theta, so I'll write it as a function of theta. This is the formula for area. We know what r is, right? So that's easy peasy. We just plug r in there. So to get the area inside one petal of the rose curve, we're going to take 1/2 times, and then let's put 2 cosine 3 theta squared d theta. And now I need to put some limits on there. But let me just, before I put my limits on, let me cancel things out. So what is that? That's the area from alpha to beta of 1/2 times 4 cosine squared 3 theta. Or in other words, the area within one rose curve is just going to be 2 alpha to beta cosine squared 3 theta. So I'm really okay. I know what I'm going to do. I know where my setup is going, right? I see where everything's going to play out. What's the antiderivative of cosine squared? What do we need? Power reducing formula. Absolutely, Taylor, thank you. So then we would apply the power reducing formula. We're not there yet. I still want to know what's alpha and beta. Now, we talked about this in class, so I know you have it in your notes. Pick any one of these curves and give me some limits that I can apply. Yeah, what do you mean?
Negative pi over 6 to pi over 6.
We could look at just this curve here, this entire curve here, and we know that that goes from negative pi over 6 to positive pi over 6. So let me erase this. And let me keep that one because that's part of my formula. Let me erase this here. And I could take and put negative pi over 6 to positive pi over 6. We could absolutely evaluate, plug those in, and get a thing. We could be even a little more tricky with our critical thinking hats. maybe pi over 6 is not a favorite of ours. Maybe 0 is a favorite of ours, because we know that our curve starts here at 0, are you with me, and goes here to pi over 6. And let me put these little parameterization dots on my curve. When I'm at the pole, I'm at theta is pi over 6. I'm at theta is negative pi over 6. And when I'm here, I'm at theta equals 0. So another thing you might want to do, instead of going from minus pi over 6 to plus pi over 6, which definitely gives me a whole curve, is you could go from 0 to pi over 6, which gives me half the curve, and double it. So that would be equivalent, and let me just erase this whole thing and show you that would be equivalent to just going from 0 to pi over 6 and doubling it, right? Because you'd want to double it to get both of the top and the bottom. Are you with me? So we could also go 2 from 0 to pi over 6. That avoids A, a negative pi over 6, and B, kind of reduces my calculations down just a little bit. So you may choose either of those to be your limits. You could also choose pi over 6 to, what did we do? Pi over 2, I think it was. I think it was pi over 6 to pi over 2 at the beginning of class. Pi over 2 to 5 pi over 6. You could also choose one of those. But I did want to show you those are your limits. I know we're almost out of time, so I don't want to rush at all and make you lose it. But I will put one more step in, because some people mess this up. Multiple people had a little mistake on the test. That power reducing formula simply reduces your power. So first of all, I think I'm going to go with the second guy where I make this 0 and pi over 6. But I do want to say one quick thing, that when you use your power reducing formula, what would it be inside? It would be 1 plus... Ooh, who wants to help me that didn't say anything yet? Neither of my Nates did anything. You want to help me? What is this going to be? One of you Nates, huh? Cosine of what in my power reducing? 6 theta? Awesome, Blossom. Thank you. Guys, you power reduced, meaning you changed it using an identity. You did not integrate. And a lot of people forgot and just started plugging limits in here. Now you have to integrate. Don't forget, now you have to integrate. Antiderivative of 1, antiderivative of cosine. Plug everything in, get an answer. And so everybody's getting... Did anybody get a number by any chance? Oh, nice. Nice. Pi over 3. I think I'm going to put 4.5 together myself so that I just get 2 in front. And then I'm going to get 2 times, you got x plus 1/6 sine of 6 theta, and you plugged in 0 and pi over 6, and that gives you 2 times pi over 6 plus the 1/6 sine pi. That goes to 0. The other piece goes to 0. Oh yeah, pi over 3. Did anybody else get pi over 3 square units? I rushed that. I just said I wasn't going to rush it, and I rushed it anyways.